Alright guys, I'm in a meeting, so I'm going to go over your warm-up, do your notes. When we get back, I'll do the SAT question and look at homework from last night. It says graph y to the equals 2 to the x minus 1. This is going to shift the graph down 1. So it's going to be here, points here, the base is 2, so it's going to be over 1 and up 2 from the asymptote. Looks like that. Domain is all real numbers. Range is y is greater than the asymptote, which is at negative 1. This one moved up 1, 0.1 above, and the negative x flips it left to right, so instead of going over 1 and up 2 here, it's going to go over 1 and up 2 to the left. It's going to be this graph. Domain is all real numbers. The range is y is greater than 1. This one, if you just add your exponents on the top, you get x to the third over negative 3, and if you over x to the negative 3, if you subtract straight down, 3 take away negative 3 is x to the 6th. This one I can distribute up, so that's x to the 5 over x to the negative 3 plus x to the negative 2 over x to the negative 3. 5 take away negative 3 is x to the 8th plus negative 2 take away negative 3 is x to the 1st. When I get back, I'm going to check all this. So here's your homework. We'll look at homework when I get back. Flipping through all that. And not going to do those examples. Okay. 3-3. Talking about logs. You'll probably like logs much better than you did exponents. Most everybody hates exponents and loves logs. What you need to know is logs are the inverses of exponents. That means to get from one to the other, you swap x and y. This is my exponential graph. This is my log graph. It just flips down. So the first thing I'm going to do is I'm going to graph my exponential graph. This is the parent graph of an exponential. Okay, and I'm going to graph it a piece at a time. The parent graph of y equals 2 to the x has an asymptote of the x-axis. Well, the log graph is the inverse. You swap x and y. So if this has an asymptote of the x-axis, this one is going to have an asymptote of the y-axis. That should make sense because we're swapping x and y. 2 to the x passes through the point 0, 1. So if I swap x and y, the log graph is going to pass through the point 1, 0. 2 to the x goes through the point over 1, up 2. So my log graph is going to go through the point 2, 1. Here. My exponential graph looks like this. My log graph looks like this. The domain of the exponential graph is all real numbers. Therefore, the range of the log graph is all real numbers because you're swapping x and y. Domain's x, range is y, so I swapped them. The range of the exponential graph is y is greater than 0, so the domain of the log graph is going to be x is greater than 0. And this is just my new parent graph. This is the parent graph for logs. Now we're going to look at some properties of logs. You should have done this last year, but if you remember it, great. If you don't, I'm going to go over it again. Now, logs naturally go with exponents because they're inverses. So my first rule is my first property is my product property that says if I'm multiplying inside of a log, I can split that up with addition. So if you had log base 3 of 9x, you can split that up, log base 3 of 9 plus log base 3 of x. I can also condense it by saying if I had log base 3 of x plus log base 3 of y, I can put that together and say log base 3 of x times y. And that should make sense that that goes together because if you think about x squared times x cubed, when you multiply like bases, what do we do with our exponents? We add them. Okay, so if you add logs, then you multiply the base, what's on the inside. The quotient rule says if you divide Division goes with subtraction, which again should make sense because if you divide like bases, you subtract your exponents. So if I had log base 3 of x minus log base 3 of y, that would be log base 3 of x over y. The rule number 3 is that if you have something in the front, it can be moved to an exponent, or you can take the exponent and move it to the front. For example, if I had 3 log base 2 of x, that's the same thing as log base 2 of x to the third. I just take it, make it an exponent. Rule number 4 is the power of equality that says if you have log base 2 of x equals log base 2 of 3, I can cancel my logs, so x equals 3. Now, that should make sense because think about 2 to the x equals 2 to the 4. You can cancel your 2's. X equals 4. In the same way that I can't do this, okay, that's illegal. I have to make them all the same first. I would have to make that 2 to the x equals 2 to the 5th, then kill them. I can't do this. Hold on. I cannot do that. Okay, that's illegal. That's improper math. Don't do that. However, what you can do is you can condense it together and say that's 3 times 5, then kill my logs. So x equals 15. You should be real careful with that. My favorite rule is to write a log as an exponent and write an exponent as a log. Now this is what I like to call the whoopsh rule. I'm not sure how loud that was in that microphone. I apologize if I blew your ears out. Examples. I'm just going to do 3 or 4. If I had log base 2 of 8 equals 3, I start with my 2. I whoosh around like a whip. And I start with my base. My base is 2. What do I pass through next? Well, I hit the 3 equals all the way back to the 8. If I had log base 5 of 25 equals 2, start with the 5. Whoosh. 5 to the second equals 25. If I had log base 3 of x equals y, it'd be 3 whoosh, to the y equals x. If I had log base star of heart equals number sign, it would be whoosh, star to the number sign equals heart. I don't care what's there, that's just the process. And then you can go the other way. Say I give you 2 to the third equals 8, and I want you to write it as a log. You would say log. You start with the base. Base. Whoosh. What do I hit next? I go through the 8 equals, where do I end up? The 3. If I had 5 squared equals 25 and I want to get backwards, I start with my 5. I write log, base 5, whoosh, of 25 equals 2. And then the final rules for logs is because logs and inverse or exponentials are inverses of each other, if you put one inside the other, that cancels and just gives you 4. Same thing here. If I had log base 2 of 2 to the 6th, it would just give me 6. Let's actually go into some examples. It says write the following in exponential form. Well, whoosh, 10 to the negative 2 equals 0.01, and that's done. So pause me for a second and try B. Okay, unpause. Start with the 8. Whoosh, 8 to the 1/3 equals 2, and that's done. It's in exponential form. I don't need to do anything else. These say evaluate. Log base 8 of 64, well, it's not equal to anything, but I don't know what it's equal to, so I can put x, and I start with 8. Whoosh, 8 to the x equals 64. I can write that as 8 squared and kill the 8's. X equals 2. Pause me and try B. Unpause. 3 whoosh, to the x equals 27. 3 to the x equals 3 to the third. Kill the 3's. X equals 3. These say solve. I don't know how to solve a log, but I know how to solve a whoosh. B to the third equals 125. I know how to solve this. I just take the cube root. If I can get rid of the log, I can solve it. B equals 5. This one, whoosh, b to the 1/4 equals the square root of 3. How do I get rid of this 1/4? I raise it to the 4th. So I've got b equals, the square root is really to the 1/2. And then 1/2 times 4 is 2. So b is 9. And these should really have parentheses around them. Here, 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 here. On C, the logs are equal. I can just kill them. So 5x plus 3 equals 45 minus 2x. Move the 2x over. Whoops. So 7x minus 3 equals 42. Divide by 7, divide by 7. X equals 6. This one, I cannot kill my logs because I don't have a log on the other side, but can I condense it? If I put it together, 4x plus 10 over x plus 1 equals 3. I still can't kill my logs because I don't have a log on the right side, but I can, whoosh, love that. 2 to the 3rd equals 4x plus 10 over x plus 1. 2 to the 3rd is just 8. Cross multiply. 8x plus 8 equals 4x plus 10 minus 4x. So 4x minus 8 equals 2. X is a half. Now that's where we actually stopped today. So let's look at your homework sheet, which is log 1. I'm going to go through and do one example from each section to make sure you know what to do. Go ahead and start this. When I get back, we'll do everything that we normally do at the beginning. Go over homework, I'll walk around and check homework, all that good stuff. Do an SAT question. Okay. One thing you need to know that I didn't mention is that if you see ln, that's log base e. It's a special log. So I'll do this one for you. This will be the one that I do out of this section. All these are the same. It says write in exponential form, so you just whoopsh, e to the x equals 65.98, and that's done. That's all you do. You just whoopsh on all those. Second set, you're going to go the other way. So you start with the 81. So it would be log base 81 of 9 equals a half. That's how you're going to do 7 through 12. And then on all these, you just say equals x. Whoopsh. 8 to the x equals 64. 8 to the x equals 8 squared. X equals 2. Now these you might have to do a little more work with. They're all just a little bit different. I'll do 28. If I rewrite it, 10 to the x equals the cube root of 10. Well, that's the same as 10 to the 1/3. So just do which ones you know how to do. Save the ones you don't till I get back. I will be back at I think I'll be back at 12. So, and you'll have the rest of the time to do this. And then those are just graphing your parent graphs. So I'll be back at 12 o'clock and decide how much you want to give.